Okay, I'd like to welcome everybody to session 7 or C07, Cloud Native Development in 4GL being put on by Querix, one of our longtime gold sponsors of the IAG. Alex, you're free to run.
Yeah, thank you, Bruce. So yeah, in this presentation, we'll see how Lycia can be used for cloud native development in 4GL. And for those of you who are not familiar with Lycia, basically it is used to run Informix 4GL applications without changing the source code and deploy them to the cloud. So let's have a quick look at one of the projects which is digitally transformed using Lycia. This is how it was before modernization. And to give you some statistics about the application, it has 5 million lines of 4GL code, 2 million lines of C code, and close to 3,000 of performs. It is an insurance application, and it has all kinds of typical classic 4GL dialogues. So yeah, nothing much to see here. And let's take a look how it is now. We did level 1 transformation here, meaning that we did not change any of the business logic. We only applied CSS and form layouts to modernize the presentation layer. On the left side, we can see application launcher menu. It comes with Lycia out of the box. It supports user authentication and group roles to control access and visibility of different programs. Lycia can work with Informix and generic compatibility modes to make the modernization phase a lot easier. And as you can see at the top of the window, classic 4GL ring menu, it works out of the box and support keyboard and mouse navigation. So let's move on to the main topic of this presentation, and we start with Lycia in Kubernetes Cluster. Let's quickly go through the main points of containerization or using virtual machines for development. Basically, it allows you to package software into standardized units for development, shipment, and deployment. It is cost effective and able to run almost in any environment. And from Lycia's side, we support installation presets. For example, for containers, you can select runtime preset, which installs minimal set of components required to run the application. And the Lycia can run almost on every Linux flavor, including Red Hat and Debian-based systems. It has rich and convenient command line interface to work without GUI. So let's move on to the next slide about the Kubernetes itself. So compared to virtual machines, it provides an easy way to scale the application. It keeps the code operational and speeds up the delivery process. And its API allows automating a lot of resource management. And on the Lycia side, we support such mission-critical features like load balancing, auto-scaling, and hot deployment. So we have prepared the video. It shows how to set up the cluster and make load balancing and auto-scaling features work. So first of all, in the cloud, and we use default configuration, pass the cluster name and location. Then we fetch cluster credentials to manage it on our local machine. And now we have to create a disk to deploy our application, and we select the 10 gigabits option. Once it is created, we deploy an FS server container to run in cluster. In its basic configuration, we specify ports and file system type. And apply. And create an FS server for our cluster with the following configuration. Finally, we create a volume itself, which we are going to use for application deployment. We specify capacity, access modes, and link to our NFS server container. And now we move on to creating a Lycia runtime container, which will serve our application. We create a secret for Docker Hub and deploy our Lycia container. In the config, we specify name, volume to attach, ports, and so on. And after this, it's time to create a load balancer service to distribute incoming requests evenly across Lycia runtime instances. In the config, we specify ports and a session affinity type. In our case, it's client IP. And we finish with horizontal pod autoscaler service. Its purpose to run new Lycia containers once incoming load reaches certain limit. In our case, we use memory utilization metric, and it is 600 megabyte. So let's check the cluster dashboard. We can see the number of running containers. The same we can check in the web-based console memory utilization. One container is running, and the host IP address. So now let's launch instance of our application and open the processes in our container. As we can see, QRun process it started and serves the application. Memory utilization started to grow. So we launch one more instance of the application, and the second QRun is started. So we do the same for a few instances of the application, and once memory limit reaches crosses 600 megabyte, the second container is started. As we can see, there are two containers running. And the same we can check in the web-based console. Two containers are running. So we can check the memory utilization of each container status. So let's ensure that previously started applications are still running on the first container. We can check the processes, and there are multiple QRun processes are running. So we start another instance of the application, a couple of them. We check that application response. And on the second container, we can see that a couple of QRun processes is created. So we run a couple more applications. And QRun processes are running on the second container. Memory utilization start to grow on the second. So both of them are serving incoming requests. The next topic is Lycia extension for VS Code. And VS Code is free, open source, and cross-platform, and has a powerful yet simple code editor. And those of you who haven't tried it yet, I really recommend to give it a try. And what's exciting that we have developed a Lycia extension for the VS Code. It makes FOGL development possible in this IDE, and it supports all standard operations like build, deploy, runtime, debug. It is possible to work from any machine with only browser installed. Basically, we run a web version of VS Code and work with our project and Lycia installation on the remote machine. Lycia extension also supports standard development operations for makefiles-based projects. We can import and work with such projects in VS Code. So let's watch a video we prepared about VS Code. First of all, we install Lycia. It takes a single command via Querix package manager. Once it is installed, we open VS Code and clone our project from GitLab. We select destination folder. Then we install the Lycia extension itself. It is located on our local file system. So we can work with the project from File Explorer or use FOGL Explorer view. It comes with Lycia extension. It shows the structure of our project, list of FOGL applications, and what's included in each of the applications. So let's start off one of our FOGL modules, and as we can see, outline view picks up the structure of the module. We can see globals, functions, reports, open windows, so on. And from the outline view, we can directly navigate to the corresponding line of code. In this case, it was open window. So we also support forms. We have a form builder, and the forms are XML based. Widgets and form structure views are available, we can view and edit forms, navigate to the corresponding element from the form structure view. So let's build one of our applications, and Lycia build system uses Ninja. It supports multi-threading, utilizing all the CPU cores and making build performance really fast. Now we deploy it. It means that no downtime required to release a new version of the application. And let's run it. Lycia uses material design theme, and this is how application looks in runtime. So let's move on to the code server part. It is a tool to run VS Code in the browser on any machine. And we install the tool. We disable password-based authentication, restart the service, and ensure that it is running. And then on our local machine, we start an SSH tunnel and forward the port. And then we open localhost port 8080. And we've got a VS Code instance running in our browser. So we follow the same steps. Basically, we open our project. And in this case, we use the remote path as we work with the project located on our remote machine. Then we also install Lycia extension. It is located on our local machine, so we use the remote path. So once it is installed, let's try to build and run the application. So as you can see from the URL, it runs on our local machine, but actually it runs on our cloud deployed machine. So let's try how debugger works. We set a breakpoint and run application in debug mode. And debugger stops at the breakpoint we set. We support all standard debug operations, including changing variable values, step through the application execution, restart debug process, or continue execution. So basically that's all about VS Code. And the next topic is REST API. It is an architectural style that uses simple HTTP calls for inter-machine communication. It is user-friendly and easy to understand for developers to code on it. And on Lycia side, we support conversion of any 4GL application to a web service in just a simple compilation. You can also expose any 4GL function by using the prefix in its name. Lycia also has a rich set of methods to communicate with third-party web services. And we can import third-party Swagger to work with Web Service API. So we also prepared the video. Let's watch it. So in this example, we first built our web service as a regular 4GL application. Build, deploy, and run. So basically, its function takes two elements and returns their sum. In our case, they are 2 and 3, and we got 5. So let's quickly check the 4GL code. As we saw, its function, and it returns the sum of 2 elements. So now we build this function as a web service. And for this example, we will also need a web client application, which will actually run our web service. So we deployed it and run our web client application. And let's check the console output. We can see that at the first step, we actually start our web service. Then we call a function, pass 2 numbers, and get their sum. And the last step, we stop the web service process. So let's take a look at the 4GL code again. We see that this function has a pub prefix in its name, and by default we use web prefix, but we can also use any custom prefix which we then need to specify in runtime environment variable, web function name pattern. So let's also check the web client code, the set of variables. In this block, we actually prepare the URL to run our web service. In this block, we actually run it. Then the next one, we call our function. And then we stop the web service in our last block. So we also prepared the video of working with external web services. And for this example, we used locate service. It's an address verification. So let's use the postcode and fetch its details.
Alex, are you still there, or is it just my screen?
I can't hear him either.
I can hear. Yeah.
Now I can hear you again, Alex. I couldn't hear you for
Yeah.
the last 5 minutes, and I also got kicked out from the session.
Oh, really? So from which part we start?
Did anyone else hear Alex, or was it just me?
I didn't hear him, Hubert, but I could see the session.
All right. Do you want to go back?
Yeah.
A bit by a couple of minutes. But basically, maybe we start with locate again, where you should a third-party web service locate.
Okay. And
That's right.
okay.
When it stopped working for me.
Yeah, basically, in this example, we saw a set of methods to work with third-party web services. And we used the locate service. It is for address verification. We use the postcode. And before pass it to web service, we prepare the string. Basically, we replace spaces with pipe. We use Regex Replace method in here. So we've got a response from web service. And below we can see the response body. So in 4GL, we use web request get method and a set of parameters for this particular web service. Then we check the HTTP code response, parse the response body into JSON array, and convert it to 4GL array via 2.4GL method. So then we fetch the details of this particular postcode, and we get the list of buildings. And we can also fetch information about this particular building. So we've got a response, and we can see its body at the bottom of the screen. So the same thing, we use web request get method and set of parameters. Check the HTTP code response, parse response body into JSON array, and convert it to FOGL array. So, and the next topic is Lycia data type. And I would like to ask Hubert to comment this one. Hubert?
Yes, thanks, Alex.
Sure.
So Alex can have a drink now to recover his voice. I'm going to tell you a bit general about Lycia and a couple of some useful data types which can become very handy when you transform your application. My name is Hubert, by the way, Hubert Hoelzl. I work for Querix and 4GL for over 20 years and was leading many 4GL application transformation projects. As Alex already pointed out, simply by compiling your existing sources with Lycia and deploying them to your application web server, the entire program or any function is already available as a REST web service. For as long the web server security allows this. So just to be clear about this, even our browser and desktop client, the graphics what you saw before, can really be seen as a client web service application, which simply interacts with the application and your web server via REST web services. From a 4GL developer point of view, a web service is not much different to a 4GL function. You're parsing arguments and returning, get data returned in form of session bodies. So the only exception is when the code requires user screen interactions. Many times, particularly in older code, presentation logic and business logic is tight, coupled together, all bunged together. So it's quite difficult. In that case, you have to add a few extra line of, let's call it posting some extra REST messages to simulate the screen interaction. So you can actually say 3 cursor jumps down, up, left, right, etc. Anything you do via the keyboard or mouse. Also, when you compile your project, as we said, you can also use your existing sources. It doesn't matter how old they are. You have to, or you can set compatibility modes. By default is of course Lycia compatibility mode, but you can set it also for classic Informix 4GL or dynamic 4GL, BDS, Genero, or Hydra. This will affect their runtime really. And also your sources, pair forms or the BDS and Genero forms, they all get transformed in the background to XML forms. Again, it's nothing what you have to do, it's done for you, transparent. So let's move back to these data types, which are quite handy when you do your work. Because over the last 2 decades, Querix enhanced 4GL with many features already to make Lycia, let's call it a 4GL, a modern 4GL programming language. And one of these many enhancements was the addition of new data types. So not just to be in line with other programming languages to say, hey, we can do this too. It's really, these are really technologies and data types which make your life easier. So when we're talking about cloud development, at the same time, we already talk about providing and utilizing REST web services. So usually you want to enhance your existing application to be accessible from other programs written in any other language or using third-party web service, which you just saw in this demo from Alex about locate, retrieve any address worldwide by any search criteria. These are features which only cost you, say, 50 lines of code and adds a complete new edge to your application. And that's not even worse to spend the time to program this yourself and pay for the data, etc., manage to maintain the data. Web service, you get these days so much value from web services, it's unbelievable. And now let's talk about a few useful other useful data types, particularly interesting when you work with transforming applications or web services. The first one, what you just saw in the last video, the Json. So when interacting with web services, particularly from other vendors and programs written in other languages, you usually need to pack all the data you pass to the web service and in JSON formatted strings. And also when you get data back, they're usually in JSON strings, JSON objects or JSON arrays. Who is not familiar with JSON, it stands for JavaScript Object Notation. It's really the most widely used data format for data interchange on the web. It's a pretty lightweight text-based data interchange format, and it's completely language independent. So any programming language has to adopt to work with the same JSON. The structure of JSON is also very simple, these objects and arrays. The data, or also known as elements, come in pairs of name and value, like primary key and data. The data objects are separated by commas, curly braces hold objects, square brackets hold arrays, and for the data type, if they're in quotes, it is a string, and without quotes is a numeric value. And of course, numeric, you can use anything, integer, double, float, it doesn't matter. So Lycia comes with a special JSON data type or object, which also comes with a rich set of object methods to simplify JSON handling. So the typical task would be reading, parsing, or writing your data in JSON formatted strings. It's simply method calls. Assigning JSON data to another 4GL variable like an array or record, again, it's simply calling a method with the argument of your 4GL variable name. Or also very interesting, something which you will see in a different presentation, when dealing with NoSQL databases, which is handled like magic for Informix and 1DB. Now, the trick consists in using cast to JSON and cast from JSON in the prepared queries, so that Lycia identifies the return data or values as JSON strings, and then you can parse it into any 4GL, well, any supported 4GL variable or object. The most commonly used one is HashMap because it's the most flexible one. And this is the one what we talk next about, yeah, HashMap. What is a HashMap? So when reading, parsing JSON data, you not even have to know what is the structure, or many times you don't even know what is the structure, what you get. So you put in a hash map, and you don't have to define columns like in a database. It's like in a NoSQL database. You have got one string where all this data are in a special format. So when it's required to apply some data manipulation in retrieving of specific data from this JSON string on the application level, or the HashMap becomes, in that case, the HashMap really becomes developer's best friend. It's to 99% you would use a HashMap really. Its data structure is very similar to JSON. Again, it's made up of keys and value pairs. It supports also objects and arrays, and of course you can also nest arrays and objects, vice versa. Data operations are very easy to implement, and a big highlight of HashMap is its performance. It's simply outstanding. So you can even apply a classic input display array directly on a HashMap. Yeah, just like you would do with a record array in 4GL, if the variable points to a HashMap, works in the same way. So the unique identifier of each element of a HashMap is the key name, again, just like primary, just like JSON, and for DB people, like a primary key or primary keys. The key can be of any data type, so it doesn't need to be a string, can be also numeric, can be even a record. So for as long it can be converted or flattened to a string, to a unique string. It can also be accessed via numerical array indexes, like any normal array. It's very untypical for hash maps, but Lycia supports this. And the array index can be really very useful when you scan or loop through all elements of a hash map. So in that case, you don't know the key names, you just loop through, get the size from the hash map. Again, it's a method get size, hash through the entire hash map, and you apply some manipulations or retrieve specific data in your loop. The hash map is keeping its data internally unsorted. So there's no order. This is a black box for the user, for the developer. But Lycia also supports sorting methods, which transparently create an ordered list of references pointing to these elements of the hash map. So you can work with this sorted hash map list, which is not, of course, no longer hash map, like it's a sorted array. And all what you work with it, but all whatever you change is then updated because these are references pointing at the hash map elements. And it is order, of course, you can order by key, you can order by value or multiple values. So you can say, I order this hash map, the data is a record by first surname and second first name. Yeah. Or age or the number, anything, whatever you want really, any number of search sorting criteria. And when you're done, you just call the method reset, sort reset, and everything is back to normal. So in summary, hash maps are handled in 4GL like any other built-in data type. It's like a container, and it comes with a rich set of methods to manage its data. These methods include functionality for inserting, deleting, searching, comparing, sorting, transforming, casting from and to strings and text files or other compatible 4GL data types, arrays, records, or again to JSON and JSON strings. So it's really a fully featured HashMap object. And I think Alex, have you got one demo, haven't you, on it?
Yep. So we have a quick demo to show a few of the HashMap methods. So on the left, we can see our HashMap.
Oh, we can't see it. Now we can see it. Now we can see it.
Okay.
It's a bit of a delay.
So the first one is delete method. We can delete HashMap element by its array index. So in our case, we remove the fifth element. And in 4GL code, we use HashMap delete method and pass our array index. We can also remove any element by its key. We pass the key and the corresponding element gets removed. In this case, it is HashMap remove method, and we pass our key value. There is also a let method. Basically, it allows you to update existing HashMap element. In our case, we update the first name, and it got updated. What happens if we change the key? If it is a unique name, it will create a new HashMap element. As we can see, the new HashMap entry is created. So basically, this method checks if a key exists. It just updates its value, and if it is unique key, it creates a new one. Another interesting method is JSON object from 4GL. We can create a JSON object from the HashMap, and we use JSON object from 4GL method and pass our HashMap. And another method is to JSON object to 4GL. So let's see how it works. We override our HashMap, and as we can see, it was recreated from the JSON object. So the method we use here is JSON parse. We pass our JSON string and HashMap. And then we've also got key exist method. We can check if some particular key exists. and if it does, it returns true. So the method is simple, key exists, and we pass our key we want to check. Then there is also getSize method. We get a size of our hash map. With getKeys method, we can get a list of the keys in our hash map. And that's all about HashMap methods we wanted to show. And this is an example of regex methods. The first one is Regex Search. We have a text. We enter the word we want to find. We've got 6 matches. And as we can see, this word occurs 6 times in this text. So in 4GL, it is Regex Search method. We pass our text and the word to find. So the next one is Regex Replace. We set words to find and the word to replace them with. So in our case, we replace Mike and George names with IAUG. So let's find and see. Yeah, as we can see, all of them were replaced with IAUG word. And in 4GL, it is a Regex Replace method. We pass our document, words to find, and the word to replace them with. So that's all about these two data types. So back to you, Hubert.
Thank you. Before I go to the next one, let's just add a few more things about regex. I assume maybe some people, well, quite a few don't know about regex. It's a regular expression. It's really a sequence of characters that specify search patterns. So this regex has got different syntaxes in different languages, but the most common ones is the POSIX standard and the Perl syntax. Actually, Perl is even more commonly used than POSIX. So in short, for regular expressions, a regex is a string of text that allows you to create patterns to match, locate, and manage text. So whenever you deal with text, regex is again another best friend for you. The first time when I had contact with regex, well, trying to understand these regular expressions, it seemed to me as like learning a different language. It's huge. It's mind-blowing. And when you spend a bit of time with it, you actually see more and more its real power and potential. There's more or less nothing what you can't do. After investing a few hours to learn it a bit more, I just realized how much time and code I can save with regex whenever I work with strings. Because I've said so before, also with web development, you do so much with JSON strings or NoSQL. It's so simple with regex and so powerful to get the data or the data manipulations on these text strings done. So I can only recommend to invest the time to learning regex really. And again, it's also not just Lycia for GL. Regex is pretty much supported in all modern programming languages. So this was just my addition to this regex. I want to talk about one more, the final data type, which again, something we have for years, and I keep seeing code coming back from potential new customers or new projects where it could save so much time. Just like references in any other programming language, we simply use a reference to parse variables by reference to functions to improve performance and have less or fewer function arguments and return values. And you will also be able to save tons of globals, what you usually see when you look at old applications. This feature was introduced many years ago, but I keep fighting to tell people, please use it. It helps, it makes it better, your code, and it makes it faster. So because this absence of references in 4GL stood for overloading your code and with globals, and just think about how many times it happened to you. You want to extract part of a code in a separate function. How you end many times up in abandon the whole idea because you have to parse and return so many different values. Values because you return the values. It is really, from my point of view, one of the greatest weaknesses of the classic 4GL language. Lycia already parses all later introduced complex data types, which we introduced the last 10 years, which were, let's say, it more complex, like, let's say, dynamic array as in a classic, or HashMap again, or Json, all these things. They already parsed by reference automatically. You don't have to do anything. So basically, you cannot even parse them by value, even if you want to. You know? But if you want to parse, say, for example, a classic record to a function as a reference, all what you have to do is you declare a reference. So like you declare any other variable, you write declare variable name reference. Reference is the data type. Second line, you use the let statement, let variable name equals sign, and the variable name of the variable you want to point it to. And that's it. From that moment on, you have got a reference to that variable, and you don't have to bother about freeing the space or a garbage collection, whatever. It's all done for you. Yeah, and this also brings me to my final topic, really, loose coupling. References, just like the Lycia cursor object, they are very helpful and can save a lot of code when breaking down large functions into a number of smaller, easier to maintain and reusable functions, more atomic functions. Maybe you all got code where you have got a function with a 15,000 line input array and you just think, I cannot even start looking at it. Yeah. So you would like to extract things like, let's say, the field validation into separate functions, but it's just such a hard job to get all the data over what you need for field validation and return, of course, things again. So references really help you there, to separate your business, also to separate your business and your presentation logic and functions. Can be nicely done. References can help you greatly. So basically, references help you interconnecting your application components to make it a more modular and maintainable system. So from my side, really, I would like to point out there is another session tomorrow, C14, which is a real-world application, a real example of using Informix and 1DB with NoSQL, Json, and HashMaps, and of course other things. The session is titled Developing IoT and Hybrid Applications with 4GL. I think, he also wrote, am I dreaming, or this is really? Yes, it is really working. And it's presented by no other than the famous Informix guru, the one who claims to have Italian roots, but drinks French wine and cannot bake pizzas. His name is Eric Verzeletto. So I would strongly recommend to see his session. And then now I pass it back to Alex.
Yeah, thank you, Hubert. So that's pretty much it. And thank you everyone for participating. We can now, in case anyone wants to know some more about any of the topics or have some questions, please feel free to ask. Hubert, have we got something in the chat?
No, it seems everyone is so happy or they all went to the pub.
Okay.
We can also unmute the microphones, Bruce, if you want.
Which I did.
Is it?
Are
there any questions from anyone? Don't hesitate. Don't be worried. There are no stupid questions. Maybe my accent is a bit different, but otherwise.
Well, I don't see anything coming up, Alex or Hubert. I'd like to thank you guys for coming and putting this presentation on, and look forward to seeing everybody later. Thank you. Have a nice day.
Thank you very much, Bruce,
thank
and
you,
thank
Chris.
you very much for everyone else for joining our
Thank you,
session.
everyone.
Bye-bye.
Bye.